plane coordinate geometry and the coordinate proof. So plane coordinate geometry is basically the same as analytic geometry. So what we do here is we shall place our geometric objects in our rectangular coordinate system and take advantage of the coordinate system. And a lot of things can spring from that, okay? We were able to discover tools such as the distance formula and a numeric value by which we can compute for the slope. So that's basically what's happening in coordinate geometry, which is basically the idea behind analytic geometry. It's geometry on your rectangular coordinate system. Now, when we place our geometric objects in our rectangular coordinate system, we must be careful with how we place those on the plane, okay? So we want to take advantage of the coordinate system. One way to make the computations easy is to place the vertices of our polygons. Okay, so if we are working with polygons, we shall place the vertices of our polygons so that all or some of them are lying on the coordinate axis. And why is that? Well, when your vertices lie on the coordinate axis, look at this. One of the coordinates is going to be 0. So for example, this is a square with side A. Okay, so what we do is we place one corner of your square at the origin. Okay, look at that. That's just 0, 0. And then we measure A units horizontally. That's one side. And so its coordinates would be A0. For the vertical side, it's going to be 0A. And this one is going to be AA. For a rectangle, we lay down our rectangle this way. Again, we are taking advantage of the coordinate system. Okay? What is a coordinate proof? You know what proof means. Proof is a demonstration that a proposition is true. You did a lot of that in junior high school math. So a coordinate proof would be also a proof, but we are using the tools from the rectangular coordinate system. So in Euclidean geometry, okay, going back to your high school math is basically Euclidean geometry. How do you establish the congruence of geometric objects? Well, what you do is you put one on top of the other, okay? And if the corresponding parts match or fit each other, then the objects are congruent. But here in coordinate geometry or using coordinate proof, we shall establish congruence by showing equality of lengths. Okay, so it's the length. So we have a tool to measure the length. That would be your distance formula, which I revealed to you is just the manifestation of the Pythagorean formula in the rectangular coordinate system. If we want to establish perpendicularity, okay, coming from Euclidean geometry, how do we establish that two lines are perpendicular? They form a right angle. But here, we can do that here without using the right angle thing. Okay, what we can do is we can compute the slope, get the product, and if the product is equal to -1, then the two non-vertical lines and non-horizontal lines are going to be perpendicular. It's the same with parallelism. Okay? How do you establish parallelism in Euclidean geometry? If the alternating angles, okay, maybe you can still recall it, are congruent. If the corresponding angles are congruent, then they are parallel. But here, we are using the tools of the rectangular coordinate system. We compute for the slope. Let us demonstrate how a proof is done using the tools of the rectangular coordinate system. Example 7. The median to the hypotenuse. Given a right triangle, the length of the median to the hypotenuse is 1/2 the length of the hypotenuse. So how do you begin this? In constructing proof, you don't go straight into the ocean. You don't jump straight into the ocean. Okay, there is a lot of behind the scenes. Okay, in your textbook, you have their polished presentation of proof, but before they were created, the writer or the mathematician had to do a lot of solving on a scratch paper. Okay, so the first thing that we must do here is, of course, we must understand what are the things that are being spoken about in the statement. Hypotenuse. So the hypotenuse is this side that is opposite to your right angle. Okay? What is the median to the hypotenuse? So a median is like a line segment. So it's a line segment whose endpoints, okay, in this case, would be the vertex of your right angle. Okay? And the median will divide or will bisect the opposite side. In this case, it's the hypotenuse. Okay? So that is what is the median is all about. It is a line segment from the vertex of one angle such that it bisects the opposite side. Now, how do we begin the proof? Well, we begin by placing our right triangle in our rectangular coordinate system. From your pre-calculus, this is what you call putting the triangle in standard position. Okay, so we shall do it in this way. The vertex angle of your right angle is going to coincide with the origin. Okay, so we shall lay down the triangle in this way. And it's going to be easy to compute for the lengths. Okay, because look at that. That is just 0. 0b, and this one is a0. Identify the statements that must be shown to be true. Okay, so somewhere here is your midpoint. Okay, so the midpoint of the hypotenuse. And we must show that the length of the median is equal to 1/2, okay, 1/2 of your hypotenuse. So that means this, okay, this is equal to that. What measurement must we use to show that measurements are true? Okay, so this is what we must show. AM, the length of the line segment AM is equal to 1/2 BC. And we will use the tools that we know from the rectangular coordinate system. We spoke about that. That would be the distance formula. When you write a proof, you begin by writing the word proof. This is a 2-column format for proof. This is what you used to do when you were in junior high school. So how do you begin? Let ABC be a right triangle with vertices A, B, and C. And angle A is a right angle. Angle A, okay, so I missed to write here. Angle A given. Next, let M be the midpoint of BC. Okay, so BC is your hypotenuse. Okay, so let me draw it here. So let M be the midpoint of BC. Okay, so we will locate here M. M has coordinates A/2 and B/2. Now, where did that come from? Well, it came from our definition of the midpoint. So given these 2 points, how do we locate the coordinates of the midpoint? So the x-coordinate is going to be equal to 0 plus A divided by 2. So that is just A/2. And the y-coordinate is going to be 0 plus B, okay, 0 plus B divided by 2, which is B/2. So that is M, and those are the coordinates. from our definition of the midpoint of a line segment. Next, the length of the hypotenuse is equal to the square root of a squared plus b squared. You can use your Pythagorean formula. You can cite it as the Pythagorean formula or Pythagorean theorem, or you can just cite the definition of the distance. So, computing for the distance, okay, so BC is equal to the square root of, 0 minus a, and then all of that squared. So that is just a squared, plus b minus 0, and then squared is just b squared. Number 4, 1/2 of BC is equal to 1/2 of the square root of a squared plus b squared. Multiplication property of equality. What is the length of the median? So this is the median. So using again your distance formula, the length of the median is going to be the square root of, the x coordinate of that point, a over 2 minus 0, and then squared, plus the y coordinate, this is the y coordinate, minus 0, and then you square it again, and this is it. So, reason, definition of length, or the definition of distance between 2 points. The length of the median is equal to the square root of 1/4 of the sum of a squared plus b squared. Definition of exponent, and 1/4 is a common factor. We just factored it out. And the length of the median is going to be equal to 1/2 times the square root of a squared plus b squared. Definition of the square root of 1/4. And there you have it. The length of the median is equal to 1/2, look at that, 1/2 of the length of the hypotenuse. Reason, transitive property of equality, or simply substitution. So this is it. So this is the illustration. Another theorem. The diagonals of a rectangle bisect each other. Again, you begin by writing the word proof. So what does it mean when the diagonals bisect each other? So pay attention to this diagonal. If the other diagonal bisects this diagonal, that means the point of intersection is the midpoint of the diagonal AC. Now pay attention to the diagonal BD. If the other diagonal bisects BD, that means the point of intersection is again that point. So what that means is we must show that the two diagonals of a rectangle have the same midpoint. That is what you must show. Again, you cannot jump straight into writing the proof. It must be clear to you where you want to go. So let ABCD be a rectangle with width A and length B, and these are the coordinates. Given the midpoint of the diagonal AC is equal to this, or this is the midpoint. These are their coordinates. A over 2 again, using your definition of the midpoint. A plus 0 divided by 2, that is the x coordinate. And the y coordinate is going to be b plus 0 divided by 2. What is the reason? Definition of a midpoint. The midpoint of the other diagonal, BD, is this. So where is BD? BD is here. Those are the endpoints. So what's the x coordinate? 0 plus a divided by 2. What is the y coordinate of that midpoint? It's b plus 0 divided by 2. Definition of the midpoint. And so there you have it. The two diagonals have the same midpoint. Conclusion, they bisect each other. In basic education, you write proof in a two-column format. That is how you used to do it way back in junior high school Euclidean geometry. But in the true community of mathematicians, and even among computer science persons, you write the proof in paragraph form. And that is what we are going to do here. Okay, so this is the claim, this is the theorem. The diagonals of isosceles trapezoid are congruent. So you must be careful about how you must lay down your trapezoid on your rectangular coordinate system. Again, we must take advantage of the axis. When you put the vertices, some of the vertices along the major axis, one of the coordinates is going to be 0. So this is an isosceles trapezoid. What again is an isosceles trapezoid? So it is a trapezoid. By definition, a trapezoid is a quadrilateral that has exactly one pair of opposite sides that are parallel. Okay? So they are parallel. Okay, so you will lay down one base here and the other there. Okay, and then you must be careful with how you will give the endpoints coordinates because they are parallel. The y coordinate is not changing. It stays as c. Okay, it's parallel to this, which is horizontal. Now, this is an isosceles trapezoid. An isosceles trapezoid is one where the legs are congruent. Okay, so this line segment is congruent to this other side. And so this is how you lay down the isosceles trapezoid, and this is how you give the vertices their coordinates. Okay, so let us prove it in paragraph form. So let ABCD be an isosceles trapezoid with these vertices. Using the distance formula, the length of one diagonal AC, okay, where is AC here? That is AC, is equal to, again, the square root of B minus negative A. And then you square it. That is this. Minus negative A. So it becomes B plus A. Plus the y coordinate C minus 0. And then you square it. Now that is the same as this one. This is the square of a binomial. And so you will just expand it. B plus A times B plus A. Okay? We go into the other diagonal. What is the length of the other diagonal? So BD is equal to the square root of negative B minus A, all of that squared, plus C minus 0, and again squared. And if you were to simplify this, okay, negative B minus A squared, that is just the same as the square of B plus A. So it's equal also to this. And so we have shown that the two diagonals have the same lengths. Conclusion? The diagonals are congruent.